Two blocks are connected by a string, and this surface on which this block can move is a smooth inclined surface, which indirectly we can say that it's a frictionless. So it means that there will be only two forces exerted on it, which I will show you when I will draw the free body diagram. And the angle is 35 degrees of the ramp, and the mass 5.7 kg, whereas this is 3.2 kilogram. In this question we have to find out the direction and the magnitude of the hanging block acceleration. Now students, this hanging block can either accelerate up or it can accelerate down, which depends upon that which force is bigger and larger, right? So let's start by drawing the free body diagram of this block. So since you see that it's placed on the ramp, that's why our rectangular coordinate system will be also like this. So I can consider this is x-axis and this is y-axis. So you can see this is x-axis and this is y-axis, and we assume that this is the block 5.7 kilogram placed at this point, and we know that the one force that will be exerted on it will be its weight, that is mg. So this is the one force, and the other force you can easily guess must be the normal force, something like this. Okay, because when we will make the component of the weight, so this is a normal force. So if we make a component of the weight, this angle is 35 degrees, and this is the one component of the weight, that is mg cos theta, whereas the other component of the weight is this, which is actually pulling the 5.7 kg downward, that is mg sine theta. So we do not draw the components in free body diagram. I'm drawing just to make equations, and don't forget that there is another force that is exerted on it, is this force of tension, so ft. So now let's draw its free body diagram, and we can see that there are only two forces exerted on it. So if this is a block whose mass is 3.2 kilogram, so the one force will be exerted upward, that is the same force of tension, which is also pulling the 5.7 kg up on the incline, whereas the another force is the weight. Now we are not sure that which force is greater, so it is how much? 3.2 times 9.8, that is 31.36 newton is the force that is pulling the mass m downward, and this is a force of tension ft. Okay, so if you see on the block 5.7 kilogram, the one force is exerted in this direction, which is the same force of tension, whereas the another force is pulling it down, which is mg sine theta. Let's calculate this force because we have all the data available. So that must be 5.7 times 9.8 times sine 35 degrees. So this force is 32.04 newton, which means that this force is dominating. It means now we are very much sure that this is a direction of acceleration in this block that must be negative because it's along the negative x-axis for the block 5.7 kg, whereas this small block m is accelerating up. All right, and that acceleration must be positive and this must be negative. So the first question that we have answered is the direction is upward, because 32.04 newton is more than 31.36 newton. Now what is the magnitude of the hanging block's acceleration? For this we can set equations. All right, because this is also unbalanced forces example. So for example, if I apply the Newton's second law for this, we know that the net force must be equals to ma. All right, so what we can write is the force of tension positive minus this capital mg sine theta is equals to m into negative a, which you can also rearrange like this. So mg sine theta minus force of tension is equals to positive ma. So we want to find out acceleration. So this is our first equation. The question, because why we are making the two equations, we don't know the force of tension as well. That's why let's go for the next equation. If we apply the Newton's second law for this mass, so it is, now I must draw the smaller arrow for the weight. All right, because now we know that the force of tension is bigger. All right, so that's why this is our net force minus mg, that must be equals to ma. So this is our second equation. So if you eliminate the force of tension by adding these two equations, all right, so if you add these two equations, what it will give us, this is positive force of tension and this is negative in this equation, so it will cancel out when we will add it, and it will give us mg sine theta minus small mg is equals to ma plus small ma, right? Because we are adding up. All right, so moreover we can take acceleration common from here. All right, and rest of the things as it is. So you can see we have made an equation. Now we have to just plug the values. So 5.7 times 9.8 sine 35, which we had already calculated, so we can directly put the value, that is 32.04 minus mg was 31.36 divided by sum of these two masses. So 5.7 and 3.2 must be 8.9. So our answer is approximately 0.08 meter per second square, which is very small value, because the difference of these two forces is not large. That's why acceleration is small. Now, not only the block is accelerating with this value, but also this 5.7 kg is also accelerating, but that acceleration will be a negative value, and this must be positive.